So, sorry it's so late, but I think I finally got it. So, it did start with a graph, so if you would like to go look at that, it's about an hour and 18 minutes into the recording from September 22nd. So that'll be it. It's chapter 5, section 5.4, but I couldn't find the presentation that he was using, so you could also just go to an hour and 18 minutes. So we have two vertical asymptotes, one at x equals -4 and one at x equals 2. We have a horizontal asymptote at y equals 1, a y-intercept at y equals -1, and an x-intercept at x equals -1 and x equals -3. So whenever you have the polynomial and you're trying to find what your x-intercept is, you set the whole thing equal to 0, the numerator, you end up just ending up with the numerator equals to 0. So that means that these x values have to be zeros of the numerator. So we have x plus 1 and x plus 3 as our candidate for the numerator, p of x. And if you look at the graph, you can see that it passes completely through at this point, and it only touches at this point. And so what that means is when something touches the x-axis and then doesn't completely cross through, it means we have an even exponent. And whenever we have any exponent, we put it to the lowest that it could be, especially when, well, only when we're doing this. We put it to the smallest that it could be. So even, the smallest it can be is 2, odd, the smallest it can be is 1. So since it crosses completely through here, this is an odd exponent. So you just put it to the first, invisible, but to the first. This one, it only touches, which means it has an even exponent. So, squared, smallest even number you can do. So now that we have our numerator candidate done, we can do our denominator. Now, our denominator, if you remember when we have one, we set that equal to 0 to get our vertical asymptotes. So we have two vertical asymptotes, x equals -4 and x equals 2. When you have them, that is the zeros of your bottom of your function. So you have x plus 4 and x minus 2. Now, you have to look at the graph in order to know this, or you could plug in values if you don't have a graph. But it goes to positive infinity to the left of this asymptote and negative infinity on the right. And then both of these are negative infinity on both sides for this asymptote, this one. So when you have that, you can actually tell what the exponent is. So if it's an even exponent, it has them the same on both sides. And if it's odd, then it has it on going to negative infinity on one side and positive infinity on the other. So that means that this one, since it has positive infinity and negative infinity, is to the exponent of 1, because again, lowest value it can be. And this one has negative infinity on both sides. So this one you also put to the second. These are both just candidates. They could be different, but the main thing is that we're only really doing one candidate. So our function ends up being x plus 1, x plus 3 squared over x plus 4, x minus 2 squared. So that is where it ends here, because we have a horizontal asymptote at y equals 1. This means that we have, if you remember, if you have x squared over x squared, and you have some numbers here, then this would give you in a horizontal, I think. A horizontal just at, yeah, it would give you sorry, a horizontal asymptote at 3/2. Well, we don't have any numbers here. Well, we have ones, but we don't have any visible numbers there. So you don't add anything onto this. And so our function is this with nothing fancy. But if you had a horizontal asymptote at, say, y equals 2, then you would have to put a 2 at the top. So keep that in mind when you do your test or any other homework, anything that's using this. Just know that you're not always going to be done at that point. But yeah, I hope this helped. Let me know if it didn't, and I can try to explain it again, like over the phone, or we can meet up in person. Yeah, just let me know.